Good morning, students. Students, this revision is for class 10th of chapter 1, Force, and today we will continue with the practical applications and numericals based on principle of moments. Children, here what is principle of moments is to be understand according to principle of moments. If the object is in equilibrium, if the object is in equilibrium, then sum of anti-clockwise moments, or you can say sum of anti-clockwise torque, is equal to sum of clockwise moments. For this, one activity was told to you, that is, if you are having a geometry scale which is of length 15 centimeter. Children, now the scale is of 15 centimeter, and if you place your finger at 30 centimeter below the scale you place your finger at 3 centimeter, you will see that the other end, 15 centimeter end, will move downward. It will depress downward, and the condition of a scale is unbalanced. The scale will be as a slanting line. It will appear like this. The scale will be going down from 15 centimeter end. So this will be your scale. It is unbalanced. It is not balanced right now. Similarly, if you place your finger at 6 centimeter, place the finger below 6 centimeter point, again the same thing will happen. The scale will depress down from the end of 15 centimeter. But if you place your finger at 10 centimeter, now I am placing the finger at 10 centimeter of the scale here, then what will happen? Your scale will not be moving like this. It won't be depressing from 15 centimeter. Rather, it will depress from 0 centimeter. But if you keep your finger at exactly half of this scale, that is 7.5 centimeter, at that case, your scale will be balanced. The upward and downward forces, these are two downward forces. The two downward forces will be balancing. Now, one force acting at 1 centimeter, 0 centimeter, will be in such a manner that it has to be pivoted, moved towards the pivoted point. Pivoted point means the point which you are using as balance point. So this is an anti-clockwise moment. What you have to do is you have to rotate the force towards pivoted point. Here the pivoted or balance point is 7.5 centimeter. Similarly, at the end of 15 centimeter, if you move this force towards the pivoted point, which is the direction? What is the direction here? Clockwise or anti-clockwise? See, it is a clockwise direction. So what you have to do? You have to move the forces acting downward towards the pivoted point or balance point to check the movement of the object. Now I have shown you figure number 5 on page number 2. This is a case of a seesaw. Children, in case of a seesaw, this total seesaw is of 4 meter length, and if you see seesaw nearby you, you'll notice that the pivoted point is always at the center of the seesaw. By center, I mean that the distance between the two ends One end to the pivoted point and the other end from the pivoted point is 2 meter each. Now, if an object of 80 newtons sits on one side and the 50 Newton person sits on other side, then rotate 50 Newton towards pivoted point. It is a clockwise rotation. And then rotate 80 newtons towards the pivoted point. So what do we find? The answer for that, we will find separately the value of clockwise and anti-clockwise moment. Children, remember that moment is equal to force multiplied by distance between the force acting and the pivoted point. So what is the distance between force and pivoted point? If I talk about clockwise moment, that was given by 50 Newton. So 50 Newton is the force and the distance between pivoted point and 50 Newton is 2 meter. So 50 into 2, 100 Newton meter. So clockwise torque produced is 100 Newton meter. While anti-clockwise moment is given by 80 Newton at a distance of 2 meter from the pivoted point, which comes out to be 160 Newton meter. Now children, if you see the two values 100 Newton meter and 160 Newton meter, which one is greater? 160 Newton meter is greater than 100 Newton meter. So therefore we will say that the seesaw will rotate in an anti-clockwise manner such that 80 Newton meter will depress down. Children, if our both the answers would have come equal, that means both clockwise and anti-clockwise moment comes equal, then we say that the object is balanced. But here in this case, the object, the seesaw, is not balanced, it is unbalanced, and thus it will not be a horizontal line, rather it will depress down from one end. So children, now question comes, how to know which one is clockwise and which moment is anti-clockwise? It strictly depends on the direction of rotational effect produced by the forces. All the weights of an object will always act downward. Children, weight of an object always act downwards. So after drawing the direction of force acting downward, you take that force and rotate it along the direction of pivoted point, as shown in figure number 6. So if you rotate it, what happens? If we rotate it, you will be seeing that one force is moving, giving an effect in clockwise manner. Clockwise manner means as the direction of needle of clock rotates, and the other will be moving in an anti-clockwise direction. So anti-clockwise is also known as counterclockwise. Counterclockwise also means the same, children, that is anti-clockwise. Now see figure number 7. What is happening here? We are having a rod of seesaw of 6 meter length. Seesaw is of length 6 meter, and from pivoted point the distances will be automatically, you will take 3 meter distance, since in case of seesaw pivot point always lies at the center. Now children, do yourself this thing. 50 Newton acting downward, 50 Newton on the other side also acting downward. Next step is to move the force to see the rotational effect. The force at point A will give anti-clockwise effect, and the force at B will give clockwise effect. So children, clockwise moment will be clockwise 50 Newton multiplied by the distance 3, 150 Newton meter, and anti-clockwise moment will also be 50 multiplied by 3, that is 150 Newton meter. Now see equation 1 and 2. Both moments are equal. Thus, in the diagram also, the seesaw is shown balanced, since clockwise moment is equal to anti-clockwise moment. Now children, before moving further, let us remember the points which we will be using while doing numerical. Point number 1 is the weight of a uniform rod or a scale is always concentrated at its center. What does it mean? It means that if you are having a ruler of 15 centimeter, its weight is acting at 7.5 centimeter. If you are having a scale of 30 centimeter, the bigger scale, then its weight will be acting at 15 centimeter. That is the central point. Central point. So a scale of 15 centimeter will have the weight acting at 7.5 centimeter, and 30 centimeter scale will have the point of weight at 15 centimeter. And from that point, you'll show the direction of weight acting downward. If anti-clockwise moment is not equal to clockwise moment, then the object is said to be unbalanced. And if these two moments are equal, then the object is said to be balanced. So now let us do some examples. First is, on a seesaw, two children of masses 40 and 60 kg are sitting on one side of it. They are sitting on one side of it at distances 2 meter and 2.5 meter respectively. Now children, respectively means that 40 kg is sitting at 2 meter while 60 kg is sitting at 2.5 meter on the same side from its middle point. Now, where should a man of 94 kilograms sit to balance it? Now, children, in this question, see what we have to do. We are having a seesaw. We are given a seesaw where two children are sitting on one side, such that child A, the first child, it's sitting at a distance of 2 meter from the pivoted point, while the child B is sitting at 2.5 meter distance from the pivoted point. Now, if both the children are sitting on one side, what does it mean? It means that the seesaw will be unbalanced. It will depress from the side where the children are sitting. So, to make it horizontal, I have to make the person sit on the other side of the seesaw. So, therefore, man will be sitting on other side of pivoted point. Man will be sitting on other side of the pivoted point, and let he is sitting at a distance of x from the pivoted point. Children, see figure number 9. Here both the children are being shown as point A and point B, such that A was of 40 kg and B was of 60 kg, sitting at a distance of 2 and 2 meter and 2.5 meter from pivoted point, and the person, the man, is depicted as, it has been shown as man who is giving a force of F. F stands for weight of the object. So children, now rotate all the forces towards the pivoted point. The forces are shown dotted. So force of the man towards the pivoted point, it is a clockwise direction, while the children are producing an anti-clockwise effect to the pivoted point, rotate it to the pivoted point. So that is an anti-clockwise direction. So now, according to principle of moments, sum of clockwise moment should be equal to sum of anti-clockwise moment. Now, clockwise moment is done by man only, whose weight was 94 kg. Children, the formula of moment is force into distance. 94 kg is not force, it is mass. So m into g is force, which is known as weight of a body, multiply by the distance which we have taken as x, should be equal to force of first child. Let it be A, first child having a mass of 40, multiply by g, and distance is 2 meters from the pivoted point, plus 60 multiply by g, and what is the distance from pivoted point? 2.5. Now in the next step, you can take g common. 40 into 2, 80, plus 60 into 2.5, 150, 94 into g into x, and then you can cancel g. Find the value of x. That will be the position where the person is sitting to balance the seesaw. The thing to remember is 40 kg child was sitting at 2 meter. If you take point A, the first child, 40 kg child, at a distance of 2.5 meter, your whole answer becomes wrong. So, first of all, draw the diagram according to the question. Directions of the force are needed to be marked, and then show the rotational effect. Understand which one is clockwise and which one is anti-clockwise, and then using the principle of moments for the object to be balanced, your clockwise moment should be equal to sum of anti-clockwise moments. So here your answer will come approximately as 2.45 meter. So children, you can do first 5 numericals on page number 11 and then try numerical number 12 and 13 on page 12. These questions are 12 and 13 are based on seesaw questions only. So retry them one more time. Thank you, children.